The notes today are on hyperbolas. We're going to graph hyperbolas and find the vertices, foci, and asymptotes. And we're also going to write the equation of the hyperbola when we're given certain information. I've cut and pasted images of a horizontal and a vertical hyperbola. What I want to do first, though, on the side is go ahead and put three-dimensionally. I'm going to put 3D. I want to kind of define what a hyperbola is. Okay, so three-dimensionally, we've been talking about our napped cones. If you take a vertical plane through two cones, that creates a hyperbola. A vertical plane through two cones. And if you go vertically, you're going to get not only one parabola, but basically two parabolas, and that's what a hyperbola is. All right, so a hyperbola three-dimensionally is a vertical plane through two cones. That's why we'd have this parabola and this parabola. Now, two-dimensionally, trying to make that go away. There we go. Two-dimensionally, it's the set of all points in a plane whose distances to two fixed points, and these points are going to be called foci. One's a focus, okay? If you have more than one, it's called a foci, and whose distances to these two foci have a constant difference. Have a constant difference. So I want you to make sure that you understand what a hyperbola looks like three-dimensionally and how you can define it three-dimensionally and two-dimensionally. All right, so let me go to kind of my highlighter. If we have a horizontal hyperbola, which means my hyperbola, if you look, is going to be going opening up to the left and open up to the right. Okay, my equation is then going to be x minus h quantity squared minus y minus k quantity squared equals 1. What's important about this is, unlike ellipses, because it's a difference, it does matter the order you put them in. If the hyperbola is on the x-axis, meaning this x-axis is going to be the major axis, then if my hyperbola is on the x-axis, okay, like it's in the x direction, it's going to be my x minus h squared first. Okay, my h and k is my vertex, and we're going to get down to here. If I could scroll down a little bit, the h and k is the center of my hyperbola. A is going to be the distance from the center to the vertex of one of the parabolas, and C is the distance from the center to the focus, right? And we're going to be able to figure out the foci, and we're going to figure out the foci using this equation. So if I'm going to highlight this, our foci equation, to get our foci, we're going to have to use c squared equals a squared plus b squared. I always remember it's opposite of the formula. So hyperbola is you have a minus in the original formula, so my foci equation is a squared plus b squared. All right. We're also going to talk about when we have hyperbolas, if you see those dashed lines, we're going to have asymptotes, and the asymptotes are going to be what helps us determine how wide those two parabolas are that create our hyperbola. Okay, we'll talk about those in a minute, but to get the slopes of the asymptotes, you're going to do plus or minus b over a. It's really going to be the way I teach it to you, rise over run. All right, so again, in the first hyperbola, when my hyperbola is opening up left and right, then my equation is going to be x minus h squared over a squared first, and then I subtract the y quantity. Whereas a vertical parabola, so now I have my parabolas facing up and down. If that is true, the y is going to be first. All right? So it's important to remember which way, which direction your hyperbola is going, because that's going to be contingent upon, or that's going to basically determine what equation we're going to use. Okay, so keeping that in mind, let's go ahead and do some examples, because I think it's going to make a lot more sense when I kind of can put this all together for you. So let's go to draw. All right, it says graph and label the vertices and asymptotes. All right, if I look at number 1, I have the x squared over 16 minus y squared over 4 equals 1. I have two square terms. I have a subtraction sign in between. That right away tells me I'm going to have a hyperbola. All right, what I do to start drawing a hyperbola is this. I need to look at those A's and B's, okay? A is basically the distance from the center to the vertex, right? The way I like doing it is this. If I have my x value, okay, look at your x value, underneath is 16. What I'm going to do is I need to determine the center first, but once I determine the center, I can go out the square root of that number in the x direction. And what I mean in the x direction is I just mean horizontally, left and right. Right now, because I didn't subtract anything from the x and y, my center is just going to be 0, 0. So I'm going to put a center of 0, 0 here, okay? From that center, in the x direction, which is horizontally, I'm going to go over 4 to the right, 1, 2, 3, 4. I'm going to go 4 to the left, 1, 2, 3, 4. All right? Now these are actually not points on my graph, all right? I'm just using these to help me determine the shape of the hyperbola. So I find my center first. In the x direction, from the center, I go out 4 units because that's the square root of 16. Now let me kind of do this in red. The y squared is over 4. So that means in the up and down or vertical direction away from the center, I'm going to go up 2 and kind of make a point for myself and down 2. And what I do with these points are actually going to make a rectangle, and this rectangle is going to help me determine the shape of my graph. So I'm going to draw a dashed rectangle because again, this is not really part of my graph. This is just how I can help determine my graph. I'm going to draw a dashed rectangle that goes up and around through all those points. And then what I'm going to do is I'm going to create a line, which is going to be my asymptote, from corner through the center to corner in both directions. All right? So I can use the values underneath the x squared and the y squared to tell me the distances away from the center. That's going to create a rectangle, and then I'm going to create 2 asymptotes. Now, in order for me to graph this, I'm actually really close, believe it or not. I have to know whether it's going up and down or my hyperbola is going left and right. If my x squared value is first, right, if you go up here, we're going to scroll back up, I know my parabola is opening up left and right. Okay, so I know that this is going to be my vertex. I'm going to have to open up, and I'm going to kind of make sure I go right along the asymptotes because that's kind of guiding my graph where it is. And the graph of my hyperbola is going to look like this. Okay, again, I know that because if the x squared is first, it's got to be going, you know, I like to say in the x direction, but I don't know if that's going to make sense. Kind of in the vertical direction, it's going to be going left and right. My parabola is opening up left and right. Okay. Now, let's go ahead and label our vertices. Well, our vertices are going to be the max or min of each of the parabolas. So this is going to be, well, I went over 4 to get there, right? So this is 4, 0. And then the other vertex is going to be negative 4, 0. And if you want, you could always write those as like plus or minus 4, 0. All right? The asymptotes, let me draw that, I don't know, and I'm just go to black. My asymptotes are the lines here. Okay, what I usually like to do is just find my slope. Like I'm going to go from this point. Let me go and kind of highlight this. I'm going to say, how much did I go up? How much did I go over? What is my slope? What's my rise over my run? If you were to actually count that out, your rise over your run, you went up 2 and then over 4. So if my slope was up 2 over 4, that's really 1/2. All right. If my slope is 1/2, my y-intercept for this example is going to be 0, 0. So when I write the equation of a line, I put in my slope, so 1/2, and then since it's plus 0, because my y-intercept is 0, that's going to be the asymptote here. It's going to be 1/2 x. And then if you look in the opposite direction, it's actually just going to be the negative of that, because if I go up to left 4, that'd be negative 1/2. So this asymptote is negative 1/2 x. So my asymptotes are y equals plus or minus 1/2 x. Okay, so I've graphed my hyperbola, I've labeled my vertices and my asymptotes. All right, if you look at number 2, the only issue with this is it's not in standard form. Okay, I always want x squared or y squared over a number minus x squared or y squared over a number equals 1, right? It needs to equal 1 and have a subtraction sign in it with 2 square terms in order to be a hyperbola. So what I'm going to do is I'm going to go ahead and take this aside a minute. I need to get this equal to 1 if it's indeed a hyperbola. So if it has to be equal to 1, what I need to do is divide everything by 729, right, each term, so that way I know this is equal to 1. Right? If you do 81 over 279, I'm going to show you over here, 81 times 9 is actually 729. So if I were to reduce these, okay, I'm going to get y squared over 9 minus, because it's kind of the opposite, I would say how many times does 9 go into that? That's going to be 81 equals 1. So this is the hyperbola that I'm going to graph. Okay? In order to graph it, let me go back to blue. I'm going to say, okay, what is my center first? The center of my hyperbola is where I need to start. My center, since I'm not subtracting the y's and the x's, and we'll get to those problems soon, but right now we're doing a lot of centers at 0, 0, just to get you guys the hang of the concept of hyperbolas in general. I'm not subtracting anything from the y or the x, so my center is 0, 0. So put in your center. From the center, let's look in the y direction, right? In the y direction, let me make this red. I'm going to say, okay, if I have 9 here, all right, then that means the value that I'm going to go, if I take the square root of 9, I'm going to go 3 units in the vertical direction, the y direction, away from my center. So 1, 2, 3, 1, 2, 3. All right, oops. 2, 3, 1, 2, 3. All right. Then I'm going to look at what's underneath the x value, and I'm going to say, okay, underneath the x value is 81. So that means I'm going to go, the square root of that would be 9 units. So I need to go 9 units in the x direction. So 1, 2, 3, 4, 5, 6, 7, I think it's the very last point. So 9 here and 9 here. Okay, I'm going to use those points to create my rectangle because that rectangle is going to help me determine my asymptotes. So I'm going here and here. Your asymptotes, again, you can draw from corner to corner through the center. So this is going to be a really, really wide hyperbola. Okay? You're almost finished, believe it or not, but I've got to figure out whether it's opening up and down or left and right. If I kind of scroll back up, if my y squared is first, my parabola is opening up and down. So I know that my parabola is going to be here, the top parabola, the bottom parabola, because hyperbola is really just 2 parabolas. I'm going to be here and here. You do want to hug those asymptotes. You want to show how wide or skinny that graph is. Okay? And what you're going to be able to see is your vertices are going to be whatever the square root is underneath the first term. So like we had y squared over 9 is where we went out 3. That's going to be 0, 3. That's going to be your vertex. 0, 3, and 0, negative 3. If I come back over here, right, it was over 16. We went out 4 in the x direction, and those 2 points were my vertices. So that's also going to help you if you want to memorize that. So I have my vertices, all right. I graphed it. I need to find my asymptotes. Well, my asymptotes are the lines, these lines here, right? So I need to find the slope. It's going to be up 1, 2, 3. So I went up 3, and then I went over 9. So if I go up 3 and over 9, that's really going to be 1/3. Since my y-intercept is still 0, 0, my equation is going to be plus or minus 1/3, sorry, that's going to be plus 1/2 x. Let me rewrite that. Draw. Equals 1/3 x, and then the one in this direction, which is going down and to the right, so negative slope, this would be y equals negative 1/3 x. So my asymptotes are y equals plus or minus 1/3 x. Okay, so that's graphing and labeling vertices and asymptotes. Let's go ahead and do the same thing, but now we're going to throw the foci in there. All right, so we're doing the same thing we did, except we have to add one more additional concept, which is going to be the foci. All right, let's look at number 1, and I'll take out as much information as I can. So I'm going to say, okay, number 1, my center is 0, 0. Right? I don't have anything subtracted from the x and the y's. So I'm going to start at 0, 0. Since my x is first, I know my parabola is going to be opening up left and right. It's going to eventually be like this. On the x-axis, I need to go out the square root of that number from my center. So 8 times 8 is 64. So I'm going to go out here and put a dot, and here and put a dot. I'm also going to know that this dot is going to wind up being my vertex. This 8, 0 and negative 8, 0 will wind up being my vertices, because whatever this number is going to be your a value, and that's going to be the distance from the center to the vertex, so those points have to be my vertices. Now, if I look on the y direction, in the y direction, my number is over 36, so I say, okay, you need to go 6 in each direction away from the center. 6, 1, 2, 3, 4, 5, 6. And I need to make a rectangle from there to be able to draw my hyperbola. So I'm putting a little rectangle here. And what the rectangle does is it allows you to have a really good picture of your asymptotes. All right, so there's my rectangle. I'm going to draw on my asymptotes from corner to corner through the center. And if I already know that since x squared is first, it's going to be going the left and right direction, I'm going to go ahead and finish drawing my hyperbola and say, hey, I know it's got to hug my asymptotes. So there's one side, and there's another side. All right, so my vertices were plus or minus 8, 0. Let's find the asymptotes. The asymptotes, again, are the lines, okay, that are kind of guiding the shape of your hyperbolas in your hyperbola. So if you go rise over run, okay, it's going to be up 6, right, over 8, because I went up 6 over 8. So if my slope is 6 over 8, divide that by 2, it's going to be 3/4. So my asymptote is going to be 3/4 x going in the up and right direction, and y equals negative 3/4 x going in the other direction. A shortcut, if you kind of are learning it, is slope is always rise over run. So if it's always rise over run, it's whatever the square root is of the number underneath the y squared over the number underneath the x squared. I don't know if that's confusing, but what I mean by that is since it's rise over run, it's going to be 6 over 8. Like I can tell my slope here once I divide is going to be whatever the number is underneath the y, the square root of that over that. If that's confusing, just do rise over run. Do what you normally do to find the slope. Okay, the last thing we need to do is go ahead and find the foci. All right, when we find foci, the foci of our hyperbolas we get by doing, I'm just going to kind of scroll up, c squared equals a squared plus b squared. So let me kind of put this in red. C squared equals a squared plus b squared. All right, so what I need to do is I need to figure out how to get my foci from the c squared equals a squared plus b squared. Well, the nice thing about the equation for hyperbolas is my a and b are going to be the distances from the center to the vertex, and then also your b squared is typically just the number underneath the y squared. So it really is going to be whatever these two numbers are. All I have to do is I just have to add together 64 plus 36. And it doesn't even matter if you have them in the right direction, meaning a or b, because I'm summing them. It doesn't matter if you put the a squared first or the b squared first. As long as you sum those two numbers, c squared is going to be 100, so my c value equals 10. All right, now you're like, well, what the heck does the c value mean? Let me scroll back up. Your c stands for the distance from the center to the focus. So if I go to my center, I am 10 units away. But am I 10 units here or 10 units here? Well, just like when we did parabolas, your focus has to be within your parabola. So if my parabola is here, if I go 10 units in this direction, that would make my focus 10, 0, and that would make my focus within the parabola. I wouldn't want to put it up here where I don't have a hyperbola. Right? Same thing here. I'm going to go a distance of 10 units out from the center and make that negative 10, 0. Okay? And that's going to be my other focus. So my foci are going to be plus or minus 10, 0. Okay? Let's look at number 2. The first thing you should notice is it's not equal to 1. I have an x squared and a y squared term, but it's not equal to 1. So let's automatically go ahead and divide everything by 288. And typically, not always, but typically the two numbers they have a lot of times will reduce to get you that complete number. So if we double check, 8 times 6 is 48. That's 24. So that is true, meaning when I go to reduce this, it's going to be y squared over 36 minus x squared over 8 is equal to 1. All right. Now let's use what we know. We know the center is 0, 0. In the y direction, I'm going to go 6 in each direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because 36, I'm looking for the square root of that. The distance is going to be 6 units. Right? In the x direction now, the square root of 8 I don't know. All right, but the square root of 8 is going to be 2 root 2. And I also know the square root of 9 is 3. So it's close to 3, but it's not 3. So what I'm going to do is I'm just going to say, okay, from the center, I'm going to go 2 and a little bit, and then negative 2 and a little bit, and create my rectangle. All right. I'm going to then, since I know the center, I'm going to draw my asymptotes through the corner to corner and the center. And if y squared is first, I know if y squared is first, right? Let's kind of scroll back up. If y squareds are first, if it's y squared minus, my hyperbola is going to be facing up and down, so I have a parabola up and down. This one's going to be a little skinnier, but make sure you make your graph go through this vertex and hug the asymptotes. So like I said before, since y squared was first, and it was over 36, this number, whatever comes first, is going to be where your vertices are. So my vertices are going to be 0, 6, and 0, negative 6. All right, so 0, 6, 0, negative 6. So let me kind of just write over here. My center was 0, 0. My vertices, you can put 0 plus or minus 6. I've got to find my asymptotes. So start from here and say, how much did I rise and how much did I run? Well, I rose 6, and then I ran the square root of 8. So let me kind of write this one down. I rose 6, and then the square root of 8 is 2 root 2. So I need to simplify that in order to be able to put that into an equation. I'm going to go ahead and reduce 2 into 6 right away and get 3. So that's really 3 over root 2. But I can't leave a radical, so I need to rationalize and make it 3 root 2 over 2. Now, I know that's not pretty, but that's okay. This is still the slope of your equation, meaning it'd be y equals plus or minus, plus would be this asymptote, the slope with a negative would be this asymptote, 3 root 2 over 2x. It's still plus 0 because my y-intercept is 0. Okay, so there's my asymptotes. The last thing I need to do is find my foci. My foci I get by doing a squared plus b squared. And again, let me just go back to the original equations. Your a squared and b squared are going to be what's underneath the x and the y coordinates. A squared's underneath the x and b squared's underneath the y. This is actually not the way we teach it. We teach it where this is going to be a squared no matter what, and this is b squared. Okay, so kind of cross that out now that I look at that. That's going to be a squared and b squared. A squared, we always talk about being the distance from the center to the vertex. Some people keep it like that, but because I think it's much easier to just know that a squared is going to be the one that's first, and it's going to be the one that has the vertices, is going to help you graph. But regardless, I know these two numbers are my a squared and my b squared. So because I'm summing them, it really doesn't even matter the order I put them in. So if I do 36 plus 8, I get 44. Now I'm going to do the square root of 44. But I'm going to say, what is that? Okay, it's plus or minus. 44 would be 4 times 11. So it would just be pull out a 2 and then root 11. Now, even though that's not fun, my focus always has to be, because c is the distance from the center to the focus within the parabola. So 2 root 11, or you can think about square root of 44. Square root of 44, well, what? 6 times 6 is 36, and 7 times 7 is 49. So in between that, this is about 6 point something, right? My graph's going to be bigger than 6, but not necessarily up to 7. But I have this point that's plus or minus 2 root 11 away. It can't be in this direction because then my focus would not be within my parabola. I have to go between 6 and 7 in this direction. Oops, here. So this would be 0 plus or minus, sorry, 0 and then just plus 2 root 11. And then down here, I would go negative 2 root 11. So this would be negative 0, negative 2 root 11. So your foci, you can kind of finish as saying it's 0 plus or minus 2 root 11. Okay? All right. Last thing we're going to do is go backwards. So we're going to find the equation of a hyperbola with the origin at the center. So you don't have to draw these, but I always like to just make a mini sketch, just like I did with parabolas. I think it's helpful. If you guys can use the formulas and determine it, that's fine. If it doesn't say graph, you don't have to. But I'm going to make a little sketch. I'm going to say, okay, if here's my xy axis, if I have a focus of plus or minus 5, 0, 3, 4, 5, I'm going to put f here. I'm going to put negative 5 right here, right? My vertex is 3 plus or minus 3 comma 0. So my focus is over 3, excuse me, my vertex, and over 1, 2, 3. Okay, right away, if I have two vertices and I have foci, I know that my vertex has to be the vertex of the parabola and the focus has to be within it. So I know automatically just by kind of making that sketch, whether you mentally do it or put it down, that it's going to be, my parabolas are going to be opening up left and right. So to me, I'm going to automatically say, because of that, I'm doing x squared over a squared minus y squared over b squared equals 1. I'm not worrying about the h and k right now just because my center is 0, 0. Right? Now, A is the distance from the center to the vertex. So that's pretty easy because the center is here. They tell me the center. To the vertex, it was 3 away. So I can automatically say, oh, A is the distance from the center of the vertex is 3. 3 squared is 9. Now, the issue comes in with, okay, what about this B squared? Well, B squared is actually the distance you get when you make your rectangle kind of from the center up. But I don't know that, okay? I'm going to have to use my foci to help me figure that out. Right? I can get up to this part of my answer, but I don't know my b squared without using my foci equation. Oops, wrong one. So what I'm going to do is I'm going to say c squared equals a squared plus b squared. Now, C is the distance from the center of the foci. Because I know my foci, I know the distance is 5, I know that's going to be 25. I know a squared's always going to be the number, the first number that's underneath whatever value squared is, which is the distance from the center of the vertex. So we said that was 9. And this way I can determine my b squared. So I'm going to say b squared is equal to 25 minus 9, which is 16. Now here's the deal. Go ahead and stop there. Because in the equation I want b squared, right? I don't have to do anything. I just want to take this number and put it here. You could determine that, yes, the b is 4, meaning b 4 here and 4 here, but you don't need to do that. In order to do the equation, you need the b squared, so just use that and stop. All right? All right, last one. I'm going to make a quick sketch just to help me determine which way my hyperbola is going. 0 plus or minus 2 is a foci. So there are my foci. One focus here, one focus here. 0, 1 is a vertex and a vertex. So that tells me my hyperbola is going to be opening up and down. If it's opening up and down with a center of 0, 0, right? If it's opening up or down, I've got to make sure, scroll back again, up and down, my y squared this time would be first. So we're using the y squared over a squared minus x squared over b squared is equal to 1. All right? To get your a squared, it's just the distance from the center to the vertex. Well, the center's here, the vertex is 1, so 1 squared is really 1. I don't know my b squared. That's what I'm going to have to determine using my foci. My foci equation is a squared plus b squared equals c squared. I know my a squared is 1. My c squared, I take my focus, right, and I square that distance. So that's going to wind up being 4. So to get b squared, I would just do 4 minus 1, which is 3. Again, I don't even care about the square root. I'm just going to put my b squared in there and be done. Okay, if you need to listen to these again, go ahead and do that, and we'll work on hyperbolas in class tomorrow.